Hi there. All right, we're going to be going through some examples. This is lesson 4.2a. Let's look at our first one. So here we're going to represent the relationship of the number of guests and cookies with a table graph and a linear equation. So looks like here we have a horizontal graph. I'm just going to take this information and write it vertically just because we're more used to seeing tables vertically. So our number of guests is X and our cookies is Y. Now remember, the cookies, being that it's our Y, that makes it our dependent variable. The cookies that we have is going to depend on the number of guests. So let's just take this information, look like guests 2, 4, 6, 8, 2, 4, 6, 8, and then cookies 4, 8, 12, 16. Just going to put the horizontal graph and make it vertical here. So the number of cookies we need depends on how many guests we will have. So now we have a whole bunch of ordered pairs. Remember here X, Y, put a comma in between, and these are ordered pairs, and we can take them then and plot them on the coordinate plane. So x-axis down here, y is vertical, so I'm going to go 2, 4, over 2, up 4, 4, 8, over 4, up 8, 6, 12, and then do you see 8, 16 is going to go off the graph a little bit, but I could just go over 8 and up maybe 16, just keep it in that straight line. Okay, so now we can see that if we connect these points, we're going to make well, kind of a straight line. Kind of. All right, so there's a linear relationship here. So now let's go ahead and see if we can write an equation. A lot of times it's easiest to write an equation by looking at the table. So if I look at the table, notice how we might be able to, on this one, look directly from the X over to the Y to see what's happening. So to get from 2 to 4, what happens? To get from 4 to 8, what's happening? To get from 6 to 12, what's happening? You can also see it up here. Remember, this is X and this is Y. To get from X to Y, what happened? To get from 4 to 8, to get from 6 to 12, do you see how it's doubling? So in order to get the Y, I would have to take the X and multiply it by 2. So I could write that equation to get y equals, what do I do to x? Well, I take the x value and I multiply it by 2. So take the x and multiply it by 2. This would be my equation or my rule for this table and this situation. So it looks like no matter how many guests I need, I'm going to need to make double the cookies to feed those guests. Now let's take a look at the pattern in the numbers. So if I look at my equation here, that constant y over x pattern should be the number that goes here. Now if you look, remember this is your x, this is your y. So let's look at the y. 4 to 8, that's adding 2. And if I look here, or sorry, not adding 2, that's adding 4. So plus 4, plus 4. And if I look here, 2 plus 4, that 2 to 4, that's a plus 2. So here if I look at the y over the x pattern is 4 over 2. So this would be 4 over 2. Well, doesn't that simplify right here to 2? Absolutely. Now, if I go ahead to look at when x is 0, well, think about if x is 0. If I have 0 guests, I would need 0 cookies. Look at the pattern. If this is going up by 2, that would continue the pattern. This would make this 0. And if this is going up by 4, if I go back 4, wouldn't that make it 0? So here we have that point 0, 0. I have no guests, I make no cookies. So here's our function rule, y equals 2x. Okay, let's look at the next example. Here we have a set of ordered pairs. We're going to organize these ordered pairs into a table. So here's my x, here's my y. Remember each ordered pair, the x comes before the y, they're alphabetical order. So I have 0, 2, then I have 4, 4, 8, 6, and 12, 8. Perfect. All right, let's go ahead and take those points, and we're going to graph them on the coordinate plane. I can use the points here in my table, or I could use the points up here. It doesn't really matter. So 0, 2. 0, and then up 2. 4, 4, 8, 6, and 12, 8. And again, we see a line, a straight line. Okay. So let's write an equation for the line. So I want to go back and I want to look at the table. Can you look straight across the table and decide what the rule is or what the pattern is? Boy, Kind of hard to do that, isn't it? Think about, what do I do to x to get y, and is it consistent? It's not. So I'm going to look for my constant y over x pattern. So y looks like this is going up by 2 between those 2 points, and it looks like it's going up by 4 between these 2 points. So my y over x pattern, y is 2, x is 4, so y over x would be 2/4, which simplifies to 1/2. So I got 1/2 there. And then when x is 0, well, I can see here when x is 0, y is 2. So when x is 0, y is 2. Now my rule says y equals 1/2 x plus 2. Let's try it. To get y, take 1/2 times x and add 2. So here's my y. I'm going to take half of this, sorry, this is my x, half of this number, which makes 6. And then if I add the 2, I get 8. It works. Let's move on to the next one. Okay, in this particular one, we're going to represent the relationship between the number of triangles and the perimeter they form. So we're going to have number of triangles and perimeter. So x will be our number of triangles and y will be our perimeter. I'm just going to write triangles here and perimeter. Our perimeter is going to depend on how many triangles we have. So we're going to create our table. So triangle 1, if I add up the perimeter, 3 plus 3 plus 4, I get 10. Triangle 2, 3 and 4. So what we want to do is just add the perimeter all the way around the outside. So 3 plus 4 plus 3 plus 4. It'd be 14. How about the third triangle? 4 and 4, 3, 4, and 3. So here we're adding all the sides up. Well, 3 4 is 12, 18. And then here all the way around, 3, 4, 4, 3, 4, and 4. Again, adding all the outside numbers together. If we add all of those together, we get 22. So here we have our table of the triangle and the perimeter. So now let's take this and put it into the graph. So again, each one of these are ordered pairs. 1, 10, go over 1, up 10. Now I have to estimate here. These are counting by 4s in between, so I want to go maybe halfway between 8 and 12 would be 10. Over 2, up 14, halfway between 12 and 16. 3, 18. About halfway. And 422. Halfway up here. Right there. It's hard with these numbers the way that they are on the side of the graph. Okay, so here I have my straight line. Something like this. All right, let's write our equation. So we're going to write our equation. We want to look across the table to see if we can determine what the rule is just by looking straight across, from 1 to 10, 2 to 14, 3 to 18. And you're probably going to find that you can't just look straight across and figure out what this rule is. It's just not a quick multiplication going across. So we're going to use the little trick here where we find the constant y over x pattern. So it looks like we're going up 4 here, and we're going up plus 1. So our y over x is 4 over 1. So I'm going to put that would be 4. Now, think about here, if I multiply x by 4. So take this, multiply this by 4, and you would get 8. How would I get to 14? What would I need to add? Let's try it here. Let's take the 1, the x value of 1, multiply it by 4. That would give me 4. What do I need to add to get across here? I'd have to add 6, don't I? Yeah, that's what I'm going to add is 6. Now, another way to do this is to go back to 0 when x is 0. So if I go back up and make x 0, so I'm going to go back up here, make this a 0, what would this number be right here? Well, remember if the pattern's going add 4 each time, what would I need to add 4 to get 10? Well, that would be 6. So I see here when x is 0, y is 6. So there's my equation, y equals 4x plus 6. All right, our next one here. The table shows the amount of water, which is y, in a tank after x minutes of being drained. So here it looks like we have a tank that at time of 0 has 440 gallons in it. But then we're draining it. So here, as the minutes increase, the amount of water in the tank is decreasing because it's being drained. So what looks like what we're going to do here is write an equation for this. Now, just by looking across the table, I can't see how I get across very easily. There's not something that I'm multiplying by every time. So I'm going to use my y over x pattern. So here's my y. Looks like I'm decreasing, but what am I subtracting by each time? Do you see it? Yeah, it's 12. Minus 12 every time. Now, okay, let's look at the y. Looks like we're adding 1. So the y over x pattern will be negative 12 over 1, which is negative 12. So negative 12 right here. Now let's find when x is 0. If you see here, when x is 0, y is 440. There we go. There's my function rule. So what this is saying is that to get y here, if I take x and multiply it by 12 and add 440, it will get me across the table. So let's try that. See if you can see my calculator here. It's kind of dark. All right. So I'm going to take the x value of 3, and I'm going to multiply it by negative 12. So negative 12 times 3. And then it says here I want to add 440. Now this should get me across the table, and it should get me 404. And you see here it does get me that. So that's the rule to get across the table. Okay. Let's take a look at these last examples where I have tables, and I just want to write the equation with you. I'm going to blow this up to make it a little bit bigger so it's easy. Okay, let's look at our first one. Now, in some cases, when we're writing our equation, we can just look straight across the table and see what's happening to get across there. Now, it looks like we're multiplying by 2 here, but that's not the case here, and it's definitely not the case here. Okay, so I'm going to need to use that trick where I want to figure out what my y over x pattern is. So I'm going to do that. Looks like from 6 to 18. I mean, even if I take a calculator and take 18 minus 6, that tells me it's going up 12. And then from 3 to 6, that's going up 3. So it looks like my y over x pattern is 12 over 3, and I know that that simplifies to 4. So that number is going to go right here. That number goes in the first box connected to my x. So what this is telling me is that I first have to take 4 and multiply it by x. Well, think about it. If you do that, if I take 3 here, this is my x value, and multiply it by 4, I would get 12. Now, what are you going to have to do to get across the table and get 6 with a 12? Do you see it? You'd have to minus the 6. Same thing here. If I take this 6, my x value, multiply it by 4, I get 24. Well, what am I going to have to do then to get 18? I'm going to have to take away 6. So right here, you're probably thinking, oh, this is minus 6. That's my rule. Well, remember, this number right here in the second box, that's when x equals 0. That number is when x equals 0. So if I go back in my table here, see 12, 9, 6, 3, go back 3, I'd have 0. We'll go back up here. So if I minus, remember the pattern is plus 12, so if I minus 12, this would be at negative 6. So I can see here too that this is minus 6. So to get across the table, I would take x times 4 and subtract 6. So this times 4 minus 6. Okay, second one. So again, let's just first start off and see if we can look straight across the table and decide what's happening. Do you see it? Yeah, it's divide by 2. So dividing by 2, that's not going to work to write our function. Because remember, our function rule says y equals some number times x. So I have to think about, okay, if this is dividing by 2 to get across the table, what's that the same as multiplying by? Yeah, you're right, 1/2. So the rule here is to get y, I take x times half. So take the x, multiply it by half, and I get the y. All right, next one. So first, just take a look across the table and see, can you determine what's happening to get across the table? Are we multiplying by something? No, this would be times 4, and that's not times 4. Okay, so that's not just going to work. I can't just look at it like I did with this one. All right, so I got y equals, let's figure out the y over x pattern here. So y looks like it's minusing by 3, going down by 3, and here it's going up by 1. So y over x pattern, minus 3 over 1, which we know that's just negative 3. So that number is going to go into our box. Okay, so now I have to figure out what's the second number that's going in the second box here. Remember, that's when x is 0. So I'm going to go back up this pattern here till x is 0 and figure out what is across from x. So that means I'm going to have to go back up one more number here. Remember the rules that we're minusing by 3? So to get back up here, I'd have to add 3. 4 plus 3 is 7. So let's try it. 7 minus 3, minus 3, minus 3. Yep, so this is going to be adding 7. Now you just want to try a rule to be sure it works. So let's take the x, multiply it by negative 3. So here's an x value. Multiply it by negative 3. See how you get negative 9? Now it says add 7. So if I add 7 to negative 9, would I get negative 2? Yeah, just want to check your rule. All right, last one here. We've got concrete blocks and what they weigh. All right, so again, first thing I want to do, even though this is a horizontal table, I just want to look across from x to y. So from x to y, x to y, x to y. Do I see what's happening to get across the table? What am I multiplying by? Can you see it? Yeah, of course you can see it. It's multiplying by 10, so times 10. And that's going to work for every single one. I mean, I could use the y over x pattern. Do you see the y here? Looks like we're going up by 50. And then the x, we're going up by 5. So if I look at my y over x pattern, is 50 over 5, which does simplify to 10. And then, of course, I could just check that and see that you're just multiplying by 10. All right, there we have it. You're all done. You know how to write function rules. Woohoo! Have a good day.